Okay, so what'd you get for this one?
496.
496. Good. So we can write it one of many ways. We have 372 miles in 6 hours. You can write it like that. So in their other ratio, miles would have to be on top and hours on bottom again so that they match up. So the 8 hours has to go on bottom. Cross, multiply, and divide. And yes, you do get 496. Any questions? Any questions off that homework on page 163, 164 from last Friday? So today we're going to start off with a bit of a review on our percents. We covered these last semester, but they're important enough I want to go over them quickly again. Remember the meaning of the word percent. Per means out of, and cent means 100. Good. So percent, like 84%, literally means 84 out of 100. In fact, it's that simple to change a percent into a fraction. Just put the percent over 100. Now, we wouldn't leave it as 84 out of 100 because that can be reduced. What can both of those be divided by? 2. We'll give you 42 out of 50. Divide by 2 again. We'll give you 21 out of 25. That's it. That's how you go. So what if I wanted to reduce 380%? I'm going to have you put that in a fraction and reduce it for me. So what'd you get? Okay, so it's 380 over 100. It's always out of 100. Yeah, that's 3 and 80 100ths. That reduces to 3 and 4/5. How many of you got 3 and 4/5? Okay. So how about 56.25%? Convert that into a fraction. What'd you get?
960.
So it becomes 56.25 over 100. And now we do have to get rid of that decimal. How do we get rid of the decimal? Well, it's got to move over 2 spots, right? So we're going to multiply by 100. So it's 5,625 over 10,000. Both of those can be divided by 625. So it is 9/16. Yeah, you could have divided by 5, 25. You'd eventually got there. I'm just being impatient today. So what if I give you 68 1/3? Actually, let me be careful. How about we do 36 2/3%? Let's do that one first. So you've got 36 2/3 over 100. We have to get rid of the fraction of 3. How do we get rid of that? Multiply by 3. So this becomes 109 over 300. Is that correct? It's 110 over 300. Then what? Both of those can be divided by? They both end in 0, so we can divide by 10. So 11/30. Any questions? What if we want to turn a percent into a decimal? Well, we said 84% is 84 out of 100. To turn a fraction into a decimal, you just divide it out. 84 divided by 100. Well, dividing anything by 100 just moves the decimal point over 2 spots. That's 0.84. So in your notes, I'm going to give you a few to do in your notes here quick. I'm going to have you do 90% into a decimal, 230% into a decimal, 7% into a decimal, 41% into a decimal, 2.38% into a decimal. Do those 5 quick. So what's 90% become? 0.9. 230%. 2.3. 7%. 0.07. 41%. 0.41. 2.38%. 0.0238. Any questions? Now, to convert the decimal back into a percent, if you recall, 0.34 as a decimal, that is per 1 or out of 1. A percent is out of how many? 100. So to get that missing number, if you cross multiply it, it's 0.34 times 100 divided by 1. Well, so in other words, you just multiply them by 100. When you multiply 100, it moves the decimal point back 2 spots to the right. So it's just 34 out of 100 or 34%. So in your notes, convert these decimals back into percents. 0.52, 0.3, 2.6, and 0.041. So 0.52 becomes what percent? 52%. 0.3, 30%. 2.6, 260%. 0.041, 4.1%. 1/4%. Turn that into a decimal. What'd you get? 0.0025. Very good. Because remember, 0.25 would still be a percent. That's just changing the fraction percent to a decimal percent. So we'll have to move it 2 spots to make it just a pure decimal. To turn a fraction into a percent. Of course, we know that 3/4 is what percent? 75. There's a couple of things we could do. We could divide it out 3 divided by 4 to make it a decimal of 0.75 and then move the decimal point. That doesn't always work so easily. So we might take something like 3/8. Think of that as 3 out of 8, and a percent is always out of 100. So we can cross multiply and divide. 3 times 100 divided by 8 is 37.5. So that is 37.5%. So the next step is to look at some simple calculations. So I want you to try these in your notes, see what you come up with. I'll put a bunch of them up here. So for the first one, what'd you get? 78. Very good. 130% is 130 over 100. Out of 60, I mean the 60 goes on bottom, so you cross multiply and divide to get 78. 20% of 90, what'd you get? 18, good. 20% is 20 out of 100. Out of 90 means the 90 goes on bottom. 240 is 30% of 800, good. 30%, 30 over 100. 240 is, the 240 goes on top, so you cross multiply and divide. 15% of blank is 12. 80, 15% is 15 out of 100. Is 12, the 12 goes on top. Out of blank means the missing number goes on bottom. Cross multiply and divide, you get 80. 32 is what percent of 40? 80%, very good. So it's blank percent, so blank out of 100. 32 over 40. 38. Missed this earlier. Nice catch. Way to lay out for it. So blank, number last one, blank percent of 70 is 48. What percent goes in there? Not everybody at once. 60, good job. So that's blank percent, so blank over 100 equals 48 over 70. You cross multiply and divide. So our next step is to take a look at what happens when you're taking a percent and you're increasing or decreasing. So for example, let's say that you estimate materials for a job at $4,600. You want to add 10% for, like waste or error or whatever. Just a 10% cushion. So how much would you charge? Well, you could find 10%. So 10% is 10 out of 100 of 4,600, which would be $460. Is that our answer? No. What do we have to do with that? $4,600 plus the 460 gives us $5,060. That's the amount we're going to have to charge. So we look at here, what we have is our estimate plus our waste or whatever we want to call it, or margin of error or whatever you want to call it. It's going to give us our total. Each of these items, as you can see, are described by a dollar amount here, but they're also going to be described by a percent. The estimate was the full amount. That was our base amount. That's 100%. We added a waste of 10%, which means the total amount is what percent? 110%. So, what we could have done rather than finding 10% was we could have found 110% of the 4,600. And when we cross multiply and divide that, that would come out to be the 5,060. Let's say you estimate a house will take 84 sheets of OSB. let's say you are going to add 15% for waste. So, how would we do this? The shortcut, what would we actually be looking for? 115%. So 115% is 115 out of 100. How much is that out of 84? So we are going to cross multiply and divide. So 96.6, right? We're going to round to 97 sheets. What do you think? Not horrible? Not horrible. Okay, so let's say that you purchase items totaling $680. Find the total after 5.5% tax. So what percent are we looking for here? 105.5. This is 105.5 over 100. Where's the 680 go? Top or bottom? Bottom. So we're going to cross multiply and divide. 105.5 times 680 divided by 100. $717.40. $717.40. So let's say after the 5% raise, you are now earning, excuse me, $19.32 an hour. Find your old ways. I'll give you guys a second to try that one. So what percent are we working with here? 105.5, or 105, right? 105 over 100. Where's the 19.32 go? On top. That is after the increase. So we're going to cross multiply and divide. 100 times 19.32 divided by 105 gives us $18.40 was your wage before the increase. What do you think? Not bad? Anybody have questions on how we did that? So let's say you charge 1.5% interest per month on past due accounts. So you build something for somebody. Generally, my contract, I had it written, certain percentage due up front, certain percentage due at the halfway point. Then everything was due upon completion. Total bill must be paid within 10 days. And then past the 10 days, some people do 30 days. I always did 10. Past that 10 days, then interest is charged at a rate of 1.5% per month. I always did 1% per month because I didn't like scrimp people, but it is standard. 1.5% a month is 18% a year, which is a standard. Either the 12% or 18% is pretty standard. I always went with the 12%, which is 1% a month. So on past due accounts, one account has a balance of so $4,263 at the end of the month. What was the beginning balance? It was the beginning of the month. See what you come up with there. So, how'd you set this up? Perfect. 101.5 over 100 equals 4263 on top. Cross multiply and divide, you get 4,200. Good deal. Any questions? So I've also talked about discounts in the past. You can get a good customer discount. As a contractor, a lot of lumber yards will give you a contractor discount. It's often referred to as a trade discount. Because you're in the trade, they give you a discount because they know you are going to be buying a higher volume of materials. You are not going to be messing around buying a lot of products and bringing them back, like buying out, taking it home, saying, oh, I don't like that or whatever. I mean, you're going to be getting stuff done. So they're going to offer you a trade discount. For example, let's say you do enough business with a local lumber yard, they offer you a 7% trade discount. So you purchase materials with a list price of $1,840. How much are you going to pay for those? Well, again, we could find the 7% of 1,840. So 7% of 1,840 comes out to be what? $128.80. That'd be your discount. But again, that's not our answer, is it? What do we have to do? We take the 1,840 and we have to subtract $128.80 to get what you pay. So you'd actually pay $1,711.20. So now again, we have the list price. This time we're going to subtract your discount to get what you pay. Well, just like before, each of these numbers is described by a dollar amount, but it's also going to be described by a percent. The list price is the full amount, 100%. The discount here was 7%, which means you paid 93%. So what we could have done there, instead of finding 7%, we could have found 93%, 100 minus 7 of the 1,840. And then when we cross multiply and divide it, it would have given us the $1,711.20. Does that make sense? So let's say that you buy a product at a promotion. Like Farrell Supply down there has their spring customer service lunch. During that day, they have tents set up everywhere, and they've got all their vendors there, and they're selling equipment at a huge discount. Usually minimum 20%, sometimes greater. Farrell Supply down there. Sometimes you guys will go down there as a group. I think last year I don't think you didn't go, but every few years you guys will go down there as a group. But anyway, so let's say you go and you get a promotional, you get a 18% promotional discount. So equipment listed for $710. What are you going to pay for it? Well, what percent are we going to deal with here? 100 minus 18. 82% is what we're going to be dealing with. Because the discount is taken away from the total, not added to it. That's why we subtract it from 100. So the 710 is the whole amount. So it's the 100%. Cross, multiply, and divide. So 82 times 710 divided by 100 is $582.20. So let's say that you are going to receive, let's do this. How much will $2,160 in materials cost you after a 6.2% trade discount? Figure that one out in your notes quick. So what percent are we dealing with? 93.8. So 93.8 out of 100. What goes over here? 2160 goes on bottom. Yes. Cross multiply and divide. You get what, $2,026.08? Any questions? So let's say after a 21% promotional discount, you pay $8,690 for equipment. How much did you save? I'm going to give you a couple minutes to figure this one out. So, what percent are you working with here? 79%. Where's the 8690 go? On top. If we cross, multiply, and divide, we get $11,000 is full price. Is that our answer? No, we're looking for how much did you save? So 11,000 minus the 8,690 is $2,310 you saved. Now, there is a way we could have done this without having to subtract. You know that little table I showed you before? So let's say we got full price minus your discount, that promotional discount equals what you paid. And again, each of those is described by percents and dollars. Well, we have 100% minus the 21% gives us 79% here, right? We use the 79% up above. We know the $8,690 goes here. What we found was this, because that's the 100%. But what we wanted was this number right here, and we could have found it directly. Because if you look at this table, you see it's just related to the 21. So, in fact, I oftentimes will actually cross, multiply, and divide right in the table. I ignore the negative. It's just 21 times 8690 divided by 79. And if I do that, 21 times 8690 divided by 79, you'll see I get that $2,310 in one step. I know a lot of people don't like doing little tables like this to map out what's going on, but you can see in these problems, if you get used to mapping things out in a little table like this, it does do a lot to save you work. I mean, it's a little bit of work to set up the table, and in the really simple problems, it's more work to set up the table than it is to just solve it. What you can see is the problems get more complex. This table, one, saves a lot of work. Two, it saves a lot of silly mistakes. So arranging your information into an organized way so that you can work with it is actually a big deal. It's a good habit to get into, put it that way. So what are some other, outside of percents, some other applications of ratios we're going to be looking at? So, we said so far we've been talking about direct proportion, direct relationship, where one number gets larger, the other number gets larger, or the one number gets smaller, the other number gets smaller. Whatever happens to one happens to the other one in a proportional manner, or rational manner. We've talked about gear ratios. Talked about pulley ratios. Talked about compression ratios. Talked about slope on a roof. Talked about pitch on a roof. Even talked a little bit about grade for ground level. All of these are direct relationships. One number gets bigger, the other number in that ratio has to get bigger as well. These ratios and these proportions can get a little bit more complex. For example, you might have 4 feet 3 inches compared to 1 foot 5 inches. Well, that's kind of ugly, isn't it? How could we simplify that ratio? Convert to just inches. Okay, 4 feet. How do we convert that to inches? Times 12 is 48. So then what? Add the 3 gives us 51 inches. How about here? 1 times 12 is 12. Plus the 5 is 17 inches. Now this can be reduced. The inches divide out. Both 51 and 17, I'm sure you see it, can be divided by 17. It's a 3-to-1 ratio. So it's a 3-to-1 ratio we end up with. Well, there are inverse ratios out there. Our inverse ratios deal with, when one number gets bigger, the other has to get smaller. For example, and we looked at, I guess that was a different group. We looked at some of these. I mean, an inverse ratio, for example, might be now we just said gear ratios were a direct ratio, right? So what's my gear ratio here if I'm assuming the motor is hooked to this one? It's a 6 to 12 or it's a 1 to 2 gear ratio, right? If you count the teeth, there's 6 teeth here and 12 teeth here. So that is a 1 to 2 gear ratio. So if I find a motor with 18 teeth, how many teeth do I have to have in the other gear? Well, I have a 1 to 2 gear ratio. If I want to maintain that ratio, 18 goes with the motor. That's always the driving gear that's on bottom. I cross multiply and divide. This ends up being 9 teeth. Make sense? That's still direct. The number of teeth on the motor got larger. The number of teeth on the other gear had to get larger. So how can this be inverse? Well, let's say that this big gear is running at 240 RPM. That smaller gear have to go faster or slower? Faster. Because every tooth of this big gear that goes through, there has to be a tooth of the little gear that goes through, right? So there's only 6 teeth on the little gear. So every time that big gear goes around once, the little gear has to go around twice to put the same number of teeth through. So this is an inverse ratio. The number of teeth gets larger, RPM gets smaller. Or number of teeth gets smaller, RPM gets larger. However you want to look at it. It's an inverse ratio. To do an inverse ratio, now a lot of your textbooks and a lot of your packets do a really funny thing where you have your teeth here. And of course this is driven over driving. So we've got 6 teeth over 12 teeth, right? But in the other ratio, they do RPM. And since this is inverse, they flip the ratio. The RPM of 240 is the driving gear, but it's going to go on top. Because we invert the second ratio, because it's inverse. So you cross, multiply, and divide. This is going to be 480 RPM. Remember, that's the RPM that goes to the driven gear, the other gear, the 6-tooth gear. To me, that's confusing because the whole point of proportions is to make this match up with that and this match up with that. Right? That's what we've always talked about. An inverse relationship, rather than being dealt with in a proportion, I think is easier dealt with as a constant product. So here we'll describe the driving gear here and the driven gear here. The driving gear can be described as 12 teeth at 240 RPM. The driven gear can be described as 6 teeth times X RPM. So 12 times 240 is 2,880 equals 6X. Divide by 6 gives us 480 RPM. Does that make sense? Sure. Let's look at another situation. Let's say we have a 12 CFM pump. Can empty a flooded foundation. So you can empty a foundation in 30 minutes. How long would it take for a 9 CFM pump? Anybody know what CFM means? Cubic feet per minute. So, went from 12 CFM down to 9 CFM. Is the time going to go up or down? The time's going to increase. Smaller pump, lower CFM, higher time, more time. So this is an inverse relationship. So we're going to have the first pump, 12 CFM at 30 minutes. 12 times 30 has to equal the second pump. What's its CFM? 9. And we are looking for its minutes. So 12 times 30 is 60 equals 9x. And you divide by 9. Come on. So you get x equals 40. It would take 40 minutes for that 9 CFM pump to empty it if the 12 CFM pump can do it in 30. Make sense? Okay. A little bit more sense at least? Okay, so I think that's enough for today. I'm going to hand out a couple more packets for you to work on. We have these packets that are going to come to you here in just a second. Also, oh, no, never mind. Nothing out of the book. I was going to say there's a piece out of the book, but there is not. So you guys have your 3 packets. I'll give you guys the last 16 minutes here to work on those.